Feed U presents Vibratory Feeder Basics. Vibratory feeders are a type of automation equipment that use controlled vibration to orient bulk, randomly oriented parts and provide a consistent feed of correctly oriented parts to a larger process. Vibratory feeders are found most commonly in product assembly applications, although they are used in packaging, inspection, and other settings as well. Common industries that use vibratory feeders include the automotive, cosmetic, pharmaceutical, electrical, food and beverage, consumer goods, appliance, and manufacturing industries, although their applications are virtually endless. In general, vibratory feeders contribute to improved line efficiency, decreased downtime, operator safety, decreased part wear, final product consistency, and much more. In process automation, consistency is key, and vibratory feeders provide a consistent and constant feed of parts in the same or similar orientation, so each segment of the process can work predictably, minimizing downtime and operator error. They specialize in applications that call for 1 to 250 consistently oriented parts per minute and improve overall efficiency while removing personnel from potentially hazardous settings. The most common style, straight wall, is the most versatile, although they can take on the walk and cascade styles to suit specific needs. All vibratory feeders feature two distinct components that make them function: the drive unit and the bowl. The drive unit mounts to the bottom of the bowl and uses electromagnetic coils to produce the vibration, typically between 60 and 120 Hz. The coils, in combination with angled spring banks, cause the bowl to throw the parts up and forward as it vibrates, creating the low friction movement that characterizes vibratory feeders. The bowl, typically constructed from stainless steel, is the component that contacts the parts and is outfitted with custom tooling concepts that physically manipulate the parts as they travel around. Feeder bowls are typically custom fabricated to suit each application and can be very simple or incredibly complex depending on the physical nature of the parts and requirements of the automated process. In addition to metal tooling features, some feeders require directed, pressurized air to properly manipulate the parts. And to satisfy even the most difficult or delicate part conditions, feeder bowls can be coated or covered in a variety of materials to reduce noise levels, excess wear, or provide extra grip or traction for the parts they are feeding. Coatings and linings include plastic compounds, bristled matting, rubber matting, metal plating, and more. Vibratory feeders impact the production of many of the products we interact with daily. And with so many custom variations, it can sometimes be difficult to interpret what kind of feeder is best for each application or why a certain feeder was selected.